Welcome everyone to our first lesson on separation techniques. So let's get straight into it. So we're going to start off by defining what we are going to be separating. And what we're going to be separating is a mixture. Now what is a mixture? So a mixture is defined as two or more different, keyword here is different things. Okay, this is a mixture, and we also want to say that a mixture with these two things, they are not chemically joined. In other words, if I had to draw a particle diagram and I had two particles, two things here, and I had two different things, and then let's say I had two more different things, this would be a mixture because these particles are not chemically joined together. So this topic and this screencast, we're going to be figuring out how do we separate this mixture, for example, using separation techniques. And there's a few separation techniques we're going to go through, and the first one we're going to be talking about is filtration. Great, let's get straight into it. Let's go a little bit further down. So filtration, you need some simple equipment. One piece of that equipment is a funnel, as you can see over here. So this thing here is a funnel. You're going to need some filter paper. So filter paper obviously doesn't look like this. It doesn't have these little gaps like this, but on a microscopic level it will have those gaps. And we need a beaker, a small beaker like this at the bottom of the funnel. So what are we going to be separating when we are using the filtration technique? Well, what we're going to be separating is a solution that has an insoluble solid inside of it. Okay, so an example might be something like sand and water. So we have sand and water as a solution, but the sand is insoluble. What we can do is we can pour that solution into the filter paper, which is sitting inside the funnel, and what will happen is the water will drip down to the bottom of the beaker, and what's going to happen is you're going to have the sand, which we call the residue, is going to be left behind. Now the question in the exam might be, why is the sand left behind? And to answer this question, if you have a look at a piece of filter paper, which I've got over here, you'll see that on a microscopic level there are these gaps between the fibers, and it's the fact that the sand particles, these particles here, are far too big for those gaps, and that's why they remain behind. So the thing that's insoluble again is the sand in the water, and the two form a solution, and we have an insoluble solid in that solution. A question in the exam might be, well, how would you attain a dry sample of the sand? And what you can say then is to rinse it once through again with some water. The water will then again drip off, and you can leave that out to dry, and all the water that's remaining within the sand will then just obviously evaporate off, and we will be left with a dry sample of sand. So that's filtration. I hope it's been helpful. See you next time.